Okay, I think we'll just probably make a start, seeing as we are just about on the half hour. So welcome everybody and good evening from a very wet and windy northeast of Scotland, and hopefully wherever you are or wherever you're listening to this, your weather is kinder and you're all safe and well, because obviously we are just off the back of one storm and we're into another, and the last one was slightly challenging. So I do know some power outages are happening across the UK at the moment, so hope everybody is safe and well. So welcome to our last event of the year. Thank you for those that have attended and stuck with us in this virtual world. Who knows what 2022 will look like? We will hopefully get back to face-to-face meetings and site visits and all the various other activities we got up to before the pandemic hit us and we started living in this virtual world. But obviously there is some challenging news coming out of the COVID situation at the moment, so we'll wait and see, and we will continue to work with the various regulations in place. Before we kick into tonight's session, I'm certainly looking forward to it and hearing from our presenters and on their insights into the North Sea transition deal. For those that are not familiar with who I am, I'm Rebecca Allison, the chair of the local Aberdeen Highlands and Islands branch for the Energy Institute, and I'm also head of emissions reduction at the Net Zero Technology Centre here in Aberdeen. So as you can imagine, this topic is of particular interest to myself in a professional and also a technical element. As I touched on, we are looking at our technical programme for next year. It will either be a mixture of virtual, hybrid, or even face-to-face, and we are pressing ahead with our annual dinner. And if Alan's on the call, as he said today, we don't know which annual dinner we aimed for, but we will be going for the 2022 dinner, which I think is one from 2020, so two-year delay, and that's in May. Tickets and tables are still available for those that would potentially want to attend, and we will keep you posted on that one as it develops. Also, I would like to thank our technical programme sponsors, Billfinger and Imran, for sticking with us during, again, we know it's been tough times for a lot of people, and delivering a technical programme over a virtual world has not been easy. So Katrina has done a sterling job to keep us going. Before I hand over to our presenters, I'd just like, we're all familiar with Zoom meetings, keep your camera off and your mics off, and use the chat function for any questions, and I will pose them to the presenters at the end. So I'm going to hand over to Rob and Chris to do introductions and basically hand the floor over to yourselves. So on you go.
Great, thanks Rebecca, much appreciated. I'll start sharing my screen now, and we'll get the slides going. Give me 2 seconds. Okay, just checking that everyone can see that okay.
Yeah, I can see it. Just put that's it in presentation mode, so perfect.
Excellent. Okay, and if you do keep me right, I've got the kind of presenter pane over here blocking some of my slides, so I may have to move it around from time to time, but hopefully it'll be okay. Okay, well, thanks everyone for joining, much appreciated. Tonight's discussion is going to be on Shell. Now I've just got need to move the pictures across because I was sitting over the title. So how Shell UK Upstream is supporting the UK oil and gas industry's decarbonisation commitments, and underlying that obviously is the commitments within the North Sea transition deal. So a very quick introduction to myself, and then I'll pass over to Chris, and then it'll be back to me for the first part of the presentation, and then Chris will take us through the latter part. So from me, I'm a petroleum engineer by background. Well, I'm actually an electrical engineer prior to that, but realised it wasn't for me when I got a couple of years into that and ended up doing petroleum engineering. Been with Shell since I graduated in 2005, and worked across a large number of brownfield and greenfield assets here in the UK. I spent significant operational time in the North Sea, but also over in the US in the Midwest of Wyoming. Fantastic experience. After that, I was in Offshore Installation Manager up in the Brent Field for 4 years, mostly decommissioning the Brent Delta, actually. Luckily enough to be on the very last helicopter off the Brent Delta before we downmanned it, and then also lucky enough to be on the Pioneering Spirit lifting vessel when we lifted it, which is where that photo is taken from, which is obviously a much fresher faced version of me back in 2016, I think, or 2017. After that, I was working within the Brent Decommissioning project for a number of years, and more laterally in January 2020 started within the newly formed UK Upstream Energy Transition team, and we'll go into a little bit about how that team works as part of the presentation as well. Chris, over to you.
Thanks, Rob. Hi, everyone. So my name's Chris Archer, and I work in the energy transition team as the opportunity analyst. I started in that role just over a year ago. And basically what I'm doing is identifying and implementing opportunities that hopefully will help Shell UK meet its climate targets. Prior to that role, I spent 9 years as a rotating equipment engineer, and I've been fortunate enough to work in both the onshore, the offshore plants, in projects, operations, and maintenance. So I have a hopefully quite a familiar view of the assets and the equipment, and that's really helped me understand where some of the avenues are to reduce the emissions on our equipment. I'm a chartered mechanical engineer, and unfortunately my photo is not from lifting the Brent Delta or any exciting operational photo. I definitely prefer Rob's one. It's a bit more exciting, but yeah, looking forward to talking you through some of the opportunities that we're looking into.
Great, thanks, Chris. Okay, moving swiftly on. So I mentioned, well, Chris and I both work in the energy transition team here within the upstream business. Maybe worth spending just a few minutes kind of introducing our team. It's a fairly unique, well, we think it's unique within the Shell upstream business anyway around the world, to actually have a dedicated full-time energy transition organization in the upstream business. So we are a broad range of skills. So there's 14 of us now. When I started, there was 5 of us, and so growing quickly with the imperative to decarbonize. The team is also growing quickly, but you know, we have essentially the full range of skills and broad experience across the upstream business, from subsurface all the way through various engineering disciplines into project management, you know, commercial, economic, regulatory affairs. Although 14 of us doesn't sound enough to decarbonize an entire business, we do have very strong links with the wider business. You could essentially, I suppose, look at us as a function where we serve energy transition up to the wider business, and then they take it on through to execution and beyond. But we can dig into that a little bit. What are we doing? So we are integrating both that kind of internal wider Shell commitments and also the external global and UK environment, to make sure that the Shell UK upstream business is ready to thrive through the energy transition. It's simple to write that down in one sentence, but as you can imagine, it's a fast moving and complex environment. So there's constant kind of absorbing of information coming from all over the place, internally in Shell and also externally, and then trying to boil that down into what do we need to do for our business is no easy task. How are we doing it? So we like I said, we collaborate widely across our internal business, but we are there to challenge the status quo, respectfully, of course. Sometimes people don't necessarily want to hear that the world is changing around them. So our job is to make sure that people are aware where the world is going, and making sure that the business stays ready to move with it. The little honeycomb things here, the top 2 are really the high level work that we do. We've generated decarbonisation forecasts and roadmaps out to 2030 and also even out to 2050. You know, obviously much more, I don't want to use the word notional, but much more imagination needs to go into what a 2050 roadmap looks like compared with the 2030 roadmap. You know, and I said we're pulling in all that external information and net zero policies to make sure that, you know, we're collaborating and implementing those across the business. So those are the two high level pieces. We then we're really involved in driving and maturing those major decarbonisation projects that I'm sure you will have heard about in various fora previously. So carbon capture and hydrogen, you know, that's essentially via the Acorn project, and there is a dedicated project team within Shell and also within the various other operators and companies that are involved in Acorn that are maturing that. So that's kind of out with our 14 strong people, but we're very closely tied into that. Similar on offshore electrification, again, there's you know, we're quite closely tied in, but there is a dedicated project team for that as well, and working closely with other operators in the central North Sea to mature offshore electrification. I think what we're here to talk about more tonight probably is some of the is how are we working on our existing assets, and what can we do in the more short to medium term to meet some of those earlier commitments in the North Sea transition deal. So Chris and I spent a large portion of this year identifying and maturing opportunities on the existing assets, and then actually working those through to execution and setting ourselves up to deliver that first 10% by 2025 that's enshrined in the North Sea transition deal. So a little bit on the North Sea transition deal. So it was a unique deal that was signed between OG UK on behalf of the upstream business in the UK and the regulator BEIS. There's 5 themes in it: supply decarbonisation, carbon capture, usage and storage, hydrogen, supply chain transformation, and people and skills. Tonight we'll definitely focus mostly on that first one. How do we decarbonise the oil and gas supply in the UK? Maybe not everybody's aware, but the oil and gas business in the UK accounts for 4% of the entire GHG emissions. So the scope of this deal is significant at a national level. And it is quite satisfying when we can look at one individual activity within our portfolio and boil it down to, you know, point something of a % of the entire GHG for the UK. You know, it is at that scale that we're working. The North Sea transition deal is against a baseline of 2018, and the commitments made in it are there on the bullet points. But you can see it's essentially 10% by 25, 25% by 2027, and 50% by 2030 towards net zero basin by 2050. I think the distinction between 25 and 27 is important. Essentially a recognition that the major decarbonisation projects like your CCS and your electrification won't be online by 2025. But there is assumptions built into those numbers that to get to 25% by 27, at least a number of those major projects will need to be in place, and then that will accelerate out to 2030 to get to the 50%. Conveniently, Royal Dutch Shell, so this is global Shell, in October this year also committed to a 50% reduction of its absolute emissions by 2030. Inconveniently, that's against a 2016 baseline. So it makes the comparisons a little bit tricky. But it is nice to see what we are, you know, the UK industry is developing, is being taken on, you know, at a global level within our business, but also I'm sure all of the other operators will be coming up with something similar if they haven't already. So a little bit on what Shell UK Upstream's footprint is. So the map on the right hand side, well, both of these are from our annual environmental statement from 2020. The map on the right hand side is essentially our upstream business, all the offshore installations, the onshore plants. Probably worth pointing out that Shell has split its upstream business in the UK. The southern North Sea is actually run out of the Netherlands. So the central North Sea, northern North Sea, and west of Shetland, and the Scottish plants Scottish onshore plants are run out of the Aberdeen office, which is the part that Chris and I are working in. But when I talk about 1.9 million tonnes per annum, that is the entire UK footprint. Obviously, all of the installations are subject to the same regulatory environment, and the North Sea transition deal. The donut that you see there, essentially just extracted from that report, is, I think in previous years, may have gone unnoticed by much of the business. What is the distinction of where our emissions come from? But over the last two, 3 years, that donut has become a lot more familiar to many more people within the business. And what that is telling us is 80% of our emissions are coming from burning fuel gas in our installations. And what's that fuel gas is going into is power generation, gas export and compression. That is the vast majority of that 80%. Flaring obviously gets a big public profile, has societal impacts, but in terms of GHG emissions, it is a smaller piece of the pie compared to fuel gas usage, and that is something that when you're working with a business that's had so much focus on flaring for so long, trying to make that distinction between flaring and fuel gas usage has been a bit tricky at times. But if we are going to make that 10% by 25 and beyond, we need to start working in this fuel gas space, but also in the flare space where we've always been working as well. You'll also see diesel is obviously 5%, and venting is 5% as well. So smaller chunks, but not to be ignored. And 1% here and 1% there in each of those as well will also help with our ambitions for that first 10% by 2025. So what Chris and I spent, I said this year, but actually it's been going on for a number of years, is developing an abatement portfolio for our operated assets. The standard tool that we use, and I'm sure other operators will be in exactly as, maybe it won't look exactly the same, but similar, is essentially what we call a greenhouse gas abatement curve. And it's a very simple, for every opportunity you have, you decide if it's pounds per ton of CO2 abated is negative or positive, and also how many tons of CO2 does it abate. So what this chart is essentially saying, the ones up below the line will actually make you money. By abating the CO2, you make more money than the activity costs you. The ones above the line will cost you money, but clearly in this picture here are the bigger opportunities. And you could imagine, like I said, this is just a generic chart that we've pulled out. But you could imagine something like CCS over on the right hand side being a nice big wide bar, similar with electrification, but expensive. Whereas something like, and what Chris will talk about, things like compressor rewheels, for example, or going to single power generator operations, much cheaper, but not as big an impact, but still chunky enough to get you that first step on the commitments. I think it's fair to say that we put a lot of effort into the energy savings opportunity scheme exercise in 2019, much more than we would have done in the past. So this is ESOS, and is a regulatory requirement for all businesses that fall into the criteria. That was probably the first line in the sand that we drew, and then since then we've been working each year with the individual facilities to work the opportunities that were identified in that exercise, but then also to keep them live. Some of them will drop off, new ones will come in. So essentially the process that we're working is in Q1, you get these idea generation sessions, and you then start working the ideas that make it through. And then in Q3, we start putting them into the business planning process. And then once they're in the plan, they get worked through to execution and repeat. In previous years, it's very much been an exercise where us and the energy transition team have been driving that with the assets. Very pleased to say that as of this year, we're now in a position where that has become much more self-sustaining within the business, and although we're still engaged with it, Chris and I in the energy transition part of the business can step away a little bit, and the ownership now sits within the assets. I think it's also fair to say that North Sea Transition Deal 25 commitment has given the operated business a license to focus on this. We've now got a strap line going of 10% by 2025, although it's an industry-wide commitment and not on any particular asset or even company. It is something good that we can hang we can hook onto as an organization and make a day-to-day business, rather than something that gets worked off to the side. I've got another minute or two, and then I'll hand over to Chris. But essentially, I just want to talk through some of the dilemmas that we've had to go through as we've been building this portfolio. And I've just taken a snapshot of some of the activities that are in the portfolio, or in fact, I'll rephrase that, have been assessed as potentially going into the portfolio. There, and you can see it's a good mix of flaring activities, venting activities, rotating equipment activities, process activities as well. So it's the full gamut of everything that causes us emissions. But what do we actually do to decide which ones we're going to work? As I said, some of them actually add value. You will make money out of doing them. So, should we be doing those ones? Although they are the smaller ones, more than likely. Should you rank these on a very simple metric of how much does it cost per ton abated? But then some of them will have an impact on the reliability of the platform. So Chris will go into more detail on single generator operations. It sounds very attractive in that you simply switch off additional generation, but then do you increase the risk of tripping the plant and therefore flaring and therefore more emissions? Some of these activities will be around methane. So anything to do with venting, for example, is methane, and obviously methane has its own commitments associated with it. Some of them will overlap with things like electrification or CCS. If you do anything on your power generation system offshore, if you're in a couple of years still planning to electrify that platform, well then would you still do both? These are the things we need to think about. When are the plants going to shut down? They all have a fixed shutdown schedule. Are your activities big enough to justify moving the shutdowns, or do you need to wait until the shutdowns come around again? And of course, resources, like everything in our business, resources are limited, and everybody has a number of priorities that they have to balance. So safety is clearly one of them, reliability and production, the kind of the three that we would normally have always said were our priorities. You now need to add a fourth one in there to the same bunch of people. So how do we prioritize that? And this is all the dilemmas that we've had to be working internally here. And I'm also convinced that there's more we can do operationally. So in our day-to-day setup, how can we set our teams up in the plants, in the control rooms, up so that they can see the impact of how they've set the plant up on that day, and then ask themselves the question, is there more that we could do, or could we do this differently? Rather than the expensive hardware changes that you see in the table above, I'm sure there's more we can do in that space as well. Okay, Chris, I've probably run over a little bit, but I'll hand over to you there.
No problem. So as Rob mentioned, and what he highlighted in the pie chart was that the majority of our emissions come from fuel gas, and most of that fuel gas is used to drive gas turbines, which provides power generation or compression power. So what are we focusing on to reduce emissions from rotating equipment? Across the portfolio of onshore and offshore assets, there are groups of opportunities that perhaps provide the best bang for buck, or the lowest hanging fruit. And one of the largest opportunities we can see is to reduce the spinning reserve. And we can see that we could potentially replicate that from asset to asset. And I'll go into a bit more detail into exactly what that means further into this presentation. But Essentially, it allows you to operate on a single gas turbine rather than operating, say, on 2 turbines or 3 turbines. Moving around the circle, so this wouldn't be possible unless you've been able to reduce the overall platform load from projects such as pump re-rating or compressor re-rating, which would essentially improves the energy efficiency of major rotating equipment. We have crude oil pumps and we have export gas compressors, and these are some of the biggest drivers on the platform. And in some cases, the energy efficiency improvements can shave megawatts of power off of the electrical load demand, which essentially means less fuel gas needs to be combusted for power generation. The equipment reliability, so this is also a key focus area. So if equipment is prone to spurious trips, and this can disrupt platform stability and sometimes lead to excessive flaring and venting or suboptimal operation. Startups and shutdowns are very inefficient modes of operation. Before generating any load, a gas turbine actually needs to run offload for a period of time as it purges the machine of any fugitive fuel gas, and also to warm up the engine. And similarly, pumps and compressors will initially recycle fluids before moving this to the next stage of the process. So keeping the process as stable as possible and reducing the number of stops and starts it is actually a way to reduce the carbon footprint of the platform. And lastly, there's flaring and venting reduction. Specifically, rotating equipment's kind of contribution to flaring and venting on a routine basis is probably quite small. There are 2 categories of flaring here. You've got continuous production flaring, which is when the plant is in normal operation, and then you've got non-continuous production flaring, which occurs during, say, emergency shutdowns. Rotating equipment can have a significant impact on unplanned, non-continuous production flaring, such as during equipment failures or faults, at which point the plant needs to be depressurized to make it safe. So there's an area here where we can play a part to reduce the flaring and venting of the platform. All of these opportunities allow using technology that's already mature. So essentially, this provides solutions to reducing the emissions before 2025. And we see this is obviously important to us, not because of just because of the North Sea transition deal, but, personally for me and also for Rob, we can see real abatements happening in the short term as well. So if you move to the next slide, please, Rob. So let's take a deeper dive into reducing spinning reserve. It's important to probably note that the efficiency for gas turbines, even relatively modern aeroderivative or light industrial gas turbines, the efficiency is not particularly high. Small to medium GTs typically are around 25% to 30% of thermal efficiency, which means basically almost 3/4 of the energy from fuel gas essentially goes straight up the exhaust. It's also important to note that gas turbines aren't fixed efficiency devices. So the instantaneous efficiency is a function of the operating load, the ambient temperature, atmospheric pressure, altitude, and the fuel type. And what you'll see on the graph on the right is a typical gas turbine performance chart. The dashed line is showing the gas turbine efficiency, and the colored lines are the different loads. So the key takeaway from this is to see that when you increase the load on a gas turbine, the better the efficiency. And the opportunity here is about looking at how we can influence how heavily loaded the machines are, or in more simplistic terms, can we run one gas turbine efficiently instead of two engines at lower efficiency? If you just click again, Rob, I think hopefully, there we go. I was hoping that would work. So what you can see obviously is we've unloaded one machine, loaded the first machine, and we basically achieve better efficiency on the A machine. So in one particular case study, we had 3 engines, 2 rated at 23 megawatts and a spare which is rated at 10 megawatts. The platform load had been around 22 megawatts, so similar to the capacity of a single engine. However, it didn't give much room for maneuver, so for process upsets or small increases in load. So what we had done originally is we optimized the running configuration to operate on the 2 most efficient engines. So that's where you see in the top left, the 144 kilotons of CO2 per annum on dual engine operation. This year, we actually managed to complete a compressor re-rating, which reduced the platform load significantly from, it was from 22 megawatts to about 14.5 megawatts. And that's basically allowed us to operate within the capacity of a single engine. So next year we'll be planning to run on a single generator. We've got some more study work to do to check the power management system and some reliability improvements to that generator before we make that step. But it has the potential to save 5,000 tons of fuel gas, and that equates to 14,000 tons of CO2 saved every year. And it's important we had to do this phased approach because it wouldn't have been possible to operate on a single engine before actually looking at reducing the platform loads. Go to the next slide, please, Rob. So the spinning reserve concept, it's not actually a new concept. It actually comes up for discussion on a regular basis. And I think that possibly the CO2 consideration gives renewed emphasis to it. It can be thought of as inertia. So essentially it helps to smooth out bumps. And one of the main issues is that spinning reserve basically aids trip tolerance or fault tolerance. So those operating the plant, will be primarily concerned with availability, because if you operate on one generator, you've got no backup, in inverted commas, to maintain the process online. So historically, what would happen is you could have 2 engines running, and if one machine tripped, the second machine could immediately pick up the load. So what we did to kind of help the business justification and try and look at some historical data and put some numerical sort of justification behind it was to look at the deferment associated with the loss of power generation and the impact of trips on the platform. When you trip a platform, sometimes you flare, so there's there's an impact there, and we had to look at that impact and understand, how many trips would it take before the fuel gas saving is essentially offset. Having that historical data really helps in having an objective discussion based on numbers. So basically, the outcome of this was that the recommendation is to run on a single engine with the second engine acting as a spare. And the benefits of this, of doing this particular project, is that it's quite minimal capex requirement. We need to study the impact on the power management system and look at any impact on when we're starting large drives such as compressors that might have large inrush currents or voltage drops. it's a fairly low complexity solution with minimal brownfield modifications, and on a kind of dollars per kilogram of CO2 abated, it's very attractive. So very high bang for buck, and that's even when you consider the costs that you would invest into perform reliability improvements on the machine. So it's definitely something that we would look to replicate from asset to asset. If you move to the next slide, please, Rob. So I'll just talk about another kind of theme that we're looking at, which is rotating equipment, rewheeling, or re-rating is the other way of describing it. Many offshore facilities have flash gas and export gas compressors, as well as oil export pumps, and these have all been designed for specific operating conditions, but over time they often end up oversized as a reservoir. Flow rates start to reduce, production declines, and they basically end up in a operating point where it operates very inefficiently and on recycle. If you just click the next one, please, Rob. So this is what happens in a lot of cases. The equipment will operate at the back end of the curve, and essentially it will recycle fluid through the machine, which leads to lots of wasted energy. If you click again, please, Rob. What we do when we rewheel the equipment is we change out the compressor internals for an upgraded bundle, which has been designed for the new operating characteristics. And basically that allows us to operate with less recycle and also operate at the best efficiency point of that equipment. It's a great initiative and a great project because it normally doesn't involve many modifications to the plant outside of the compressor boundary. So you can execute this kind of activity in, a turnaround or maybe an extended pit stop, and wherever possible, the surrounding equipment and the piping is retained. So you save in terms of cost and downtime. It's done to save energy, but it also can help debottlenecking or process changes. So there's also a good business justification there as well. You move to the next slide, please. So just to give you kind of an idea of the impact of one particular project on one of our assets. So the project that happened this year, we had the compressor bundle changed on an offshore platform. The bundle itself is roughly £3 million, not excluding all the engineering and design work that goes along with that project as well. But it obviously shows you that the actual material component cost is quite low. The CO2 savings, so currently we're seeing 35,000 tons of CO2 per year reduction when the power is provided by 2 engines. And next year, when we operate on a single engine, that will further go down to go up to 49,000 tons of CO2 per year reduction. On the right, you can see this is kind of to try and paint the picture of the impact of the CO2 saving on a kind of in everyday life. So 49,000 tons of CO2 per year is equivalent to 100,000 transatlantic flights from London Heathrow to JFK, or it's equivalent to turning off all of the houses in Peterhead, Inverary, Fraserburgh, West Hill, Stonehaven, and Ellen. So there's dropping the load from 22 megawatts to 14.5 megawatts has a significant impact on our overall emissions profile. What you can see in the images at the bottom, so these are the actual pictures of the the bundle change that happened this year, piece of quite heavy equipment being lifted through the platform and into the berth where it sits. And then on the graph on the right, you can see the fuel gas flow. Basically, you can see the impact of the project, which midway through you can see a step change reduction in the fuel gas flow. Personally for me, I think it's great to see the real impact of the project and that we're delivering real CO2 savings. So this was one of our biggest activities this year for emissions reduction. If you move to the next slide, please. So that is the end of the slide pack, actually. So I think we'll leave it there, and we will go ahead and answer some questions. I'll hand back to Rebecca, please.
Thank you, Chris and Rob. Hopefully I will stay with you. I've noticed that my internet connection is going a little bit troublesome, so hopefully I stay with you for the next 20 minutes or so. One of the things, and there's a few bits and pieces on the chat, but I just want to pick up on part of the earlier sort of discussions, and it's also something I'm quite familiar with. You know, when we say that the oil and gas sector accounts for 4% of all the emissions within the UK, do you think the public are really aware of that? Because to me, it doesn't seem a huge amount, when considering we are seeing the fossil fuel industry does seem to be one of the biggest contributors, but 4% doesn't actually, you know, we're not one of the worst offenders. I'm not saying we shouldn't be working on it, but do you think we need to raise a bit more awareness that actually we are part of a bigger picture and a whole community needs to work together across the UK to get our emissions down? So
yeah, Rebecca, I'll take that one. Just checking everyone can hear me.
Yeah.
Excellent. Am I sharing my screen still? I think I am. Or have I stopped? Oh, I think I've stopped. Hang on a second. I'll just get the slide pack back up. Is that coming through?
Yeah.
Yeah. Okay, great. Yeah, thanks, Rebecca. I think I would have come from the other side, actually. When I saw that 4%, I actually thought that was quite a larger chunk than I was aware of at the time. I always thought the biggest emissions, or the significant part of the oil and gas business, was in the burning of the products that we create, rather than in the creation of those products in the first place. So for me, just seeing the numbers in the North Sea transition deal was eye-opening, and I suppose from an engineering perspective was quite satisfying that, you know, like I said earlier, individual jobs, individual activities like the one that Chris just showed can actually move. Maybe moving the needle is an exaggeration, but you can see the impact of our jobs on that number, and in a UK national perspective. In terms of what the industry needs to do to say whether that number is too big or too small, I'm not sure I'm qualified to say on that. You know, there's obviously been a huge amount of discussion recently about offshoring of emissions and what where the UK needs to go in terms of its domestic production versus importing production. But again, I wouldn't be qualified, I don't think, to comment further on that. But that 4% is the number that is associated with the domestic production. Yeah,
and like I say, it's eye-watering, but then it's other times people look at it and go, oh, 4%. So I'm sure the other sectors, other industries within the UK are also working on some of their targets. So it will be interesting to see how we can do it as a collective. And maybe again, as you're on, Rob, about we hear energy transition used a lot. You know, it seems to be, you know, it's either net zero or energy transition. What do you think the main challenges are going to be? Is, you know, as part of that discussion, energy transition is about, you know, decarbonising our current industry and blending it into the future energy demands. other than, I mean, I know we'll touch on the actual project stuff from the alternative power side of things, but what do you think some of the biggest challenges are going to be in that sense of really getting into the full energy transition piece?
Yeah, no, good question. I think when I talk about those major projects, that's when you're getting into what maybe other. Yeah, I think you're right. Energy transition is used very broadly. Is it as simple as decarbonisation of existing assets, like we've talked about? And I say simply in inverted commas because it's not simple. Or is it that plus blue hydrogen plus CCS plus electrification of everything? For me, it's all of those. In our business, anyway, that's in the upstream business. That's what it is. The kind of big challenges in getting those big projects over the line is simply right now they're so expensive, and there's a long lead time on them, and which is why we're, as part of the North Sea transition deal and some of the other initiatives that BEIS are working, that recognition from the government that there will need to be support to get some of these bigger projects over the line and into that the kind of the beyond 10% piece, I think is really important.
Yeah, I mean, I think a lot of the debates or discussions have been that the amount of investment that's needed is one of the biggest challenge, and in a very resource constrained world, whether it's or resource, even from a skill set, we'll need a large investment from not only our own industry but from government or the investment arms, private sector, to help support us. So yes, I think we can do some inroads into it for that first 10%, but beyond that, we are going to need that support to truly. And
I think the onus is on us as well to bring the cost of those projects down to as much as we can. But then even then, it's clear that they will need to be supported, at least in those kind of early pathfinder projects that will kind of set the scene for the ones to follow. Yeah.
And Chris, just actually discussing the actual projects and some of the rotating equipment challenges. I mean, Bob's put it in the chat a couple of times on, some of this is best practice, reducing load, obviously reduces maintenance costs. So has there been any real reason prior to sort of, the initiatives that we're working on and the focus, but has there been challenges associated with that in the past? Has there been a technical issue or even an investment or just a lack of awareness of some of the work that you've been doing previously? Or is it just the fact that it's now really being brought to focus and it's now a good opportunity to get some of these smaller or best practice type projects up and running?
Yeah, I think there's definitely been an awareness. I think there's been I guess a view or an impression that running two engines is a more reliable and a more stable form of operation compared to just operating on, say, one engine. That may not always be the case, because sometimes when you operate two engines, you actually have to operate them in, unreliable modes of operation, and actually you can actually lead to early degradation of the engine operating in that manner. I think like the comment on that this is best operating practice. Yeah, I think there's a lot of opportunities that we have where it could be considered as best operating practice. I think the difference now is that obviously there's a renewed focus with reducing the emissions, and previously I think because of the reluctancy to go for some of these projects because of the potential impact on stability, and with plant stability there comes a potential impact on HSSE, because you don't want an unstable plant with people having to manage very dynamic situations. You'd like to keep it as stable as possible, and not have operators running around trying to switch on, say, a second generator. I think maybe that is kind of the the vision that people have is when we start talking about operating on a single generator, there is maybe a bit of there was a reluctancy, but now actually going into this level of detail, really understanding the data, the impact of operating on one generator as opposed to two, and looking at, say, rewheeling a machine to improve its reliability and its GHG reduction. I think it's being brought a renewed focus on these projects. So they are being resurfaced. The good thing is that because they're not new concepts, it means that we can actually implement them kind of almost off the shelf in the short term. It doesn't need to wait for years of study or technology maturity or R&D. So I think, yeah, I think that's probably the reason why maybe they haven't been done historically. And perhaps there are other projects that people have thought provide bigger benefits, and maybe it's been dismissed before because there hasn't been looked at the economics in detail.
I think it is fair to say, I mean, a lot of projects and a lot of changes that come through. I mean, we've seen it in other initiatives, not just, any sort of engineering or technical changes. And, there's a big management of change piece behind there as well. It's sometimes not just the technical issue, but either the operating side of things and also then potentially any further impact. So there is always a slight element of that we need to consider lots of other elements within that process of changing something to a different approach. And I'd imagine, like most companies, that whole change process can sometimes be a little bit slower than we would like, just because of the various things that people need to go through, and especially when you're trying to do that either remotely or when organizations are going through some significant changes and strategy changes. So I could sympathize that, yes, best practice sometimes comes with that. Oh yes, why didn't we do that? But it's not always as easy as that. Other thing was, and it's probably something that's quite close to my own sort of day job as well, is have you guys been looking at any thoughts on the alternative fuel side of aspects of it, from also fuel gas? And I think Peter talked about, do you have to pay for fuel gas? As a royalties, as a tax, is there a benefit to using fuel gas over alternatives? But obviously, if we don't use fuel gas going forward, have you looked at any of the synthetic or other blended type low carbon options?
Yeah, we have actually.
Chris, why don't I take the first bit of that question, because I did see it come through in the chat, and then I'll hand over to you because I know you're deep into some of this. But one of the questions was around what do you pay for fuel gas? I think that's quite an interesting one. So, effectively, you don't pay. We don't pay for it. We use it, but what we lose is the value of selling it. So that is something that we need to take, and that helps the economics. Of course, the less fuel gas you're using in your process, the more you have available for sale, and therefore supports some of the jobs, the opportunities that Chris has mentioned earlier. The question could then obviously be, well, someone's going to burn that fuel gas anyway. And that is absolutely true. But what it means is there's more gas available in the system from domestic production, and therefore less requires to be imported. So kind of UK PLC should be winning in terms of total emissions in that. The other piece, of course, is the emissions trading scheme. We do pay, for hydrocarbons that we burn and turn into CO2. So fuel gas, diesel, and flaring. If you remember that donut that I shared, those are the ones that you pay emissions trading scheme on. Things like venting and fugitive emissions, actually, you don't. So again, that comes into economics, for the opportunities that you pursue. Chris, maybe hand it back to you to talk about some of the alternatives that we're considering.
Yeah. So just on that question about alternative fuel. So yes, we are actually looking at alternative fuels. I mean, some of the ones that have been mentioned and we've had a look at initially was hydrogen fueling for gas turbines. So we did we've not started any work on that because, you know, we need to understand where that hydrogen will come from. Those machines will need to operate with huge volumes of hydrogen on an offshore platform. And the first problem there is how you're going to get the hydrogen over there, and where is it coming from? How is that sustainable? So that's probably the biggest, you know, hurdle to overcome first. The other alternative fuels we're looking at, so we're looking at biofuels and the potential to use biofuels for some of the rotating equipment. That's, you know, very much in the early phase at the moment, but the great thing about using biofuels is there's equipment on vessels, you know, vessel logistics, that can also use biofuels as well. So it perhaps extends to the supply chain as well as, you know, the actual platforms themselves. So yeah, we have been looking at alternative fuels. I guess, yeah, we've not really been looking into some of the more out there options just yet. I know there's things like methanol and there's all sorts of synthetic fuels available or being developed. I think, yeah, we haven't got there yet, and I think some of the OEMs that serve our rotating equipment, they're still quite, you know, in a relatively immature sort of part of the technology journey at the moment. So yeah, we're monitoring the progress of those technology developments, but biofuels is probably the kind of strongest contender from a sort of alternative fuel at the moment, for rotating equipment that can't be say electrified, for example.
Yeah, I think that'll come. Yes. Oh, sorry, Rob.
No, I was just going to say, I think it's worth pointing out that what's really important is that we don't do this as a broad brush. We will go into biofuels for everything Shell UK offshore. You know, every platform is its own special, unique process, and some of them use a lot more diesel, for example, than others, simply because they were never hooked up to the fuel gas system. So therefore, for those particular assets, well, then we would be more looking down the route of, well, what can we look at as alternatives to diesel usage? Whereas on the ones that are much more fuel gas based, well, then we'll be looking at how can we actually reduce demand or increase efficiency. And so yeah, it's very much, and I think that plays to that first point where you really need to get into the data for each individual asset to find out what the best opportunities are for that particular asset. And if you ever have the pleasure of going through Chris's long list of opportunities, it is hundreds and hundreds of ideas long, and trying to boil that down to just the right ones for each individual asset is a tricky exercise.
Yeah,
I spoke over you.
Yeah, totally with you on that one. You know, it's the projects that look at full scale electrification to the alternative fuels, from small mobile equipment to the big gas turbines. It's going to be a complex future for all of that whole energy or zero emissions power element, and also, let's say, quite dear to my heart in my day job. Do realise that it's not a one fit for all. We've just got a couple more minutes before we finish up, and I know we've sort of concentrated very much on the rotating equipment side for you guys, but as Bob had sort of said, and when you did your donut, 16% of your emissions come from flaring and venting. So that's obviously, you know, usually the other element that people look at from their emissions. So it's maybe not so much in your remit or in your day-to-day, but is there any thoughts on what you're planning to do in that side of things from the flaring and venting?
Do you want me to answer, Rob?
Maybe I'll talk.
Yeah.
I saw the comment coming through, so maybe just one thing to clarify. So what we're looking at here is CO2 equivalent. So although that 5% that is venting, that would be, if you did this on tons of methane and tons of CO2, that would be a much smaller number. But because of the higher the climate impact of of that methane, it gets bumped up in terms of CO2 equivalent. So in terms of climate impact, this donut kind of takes account of the fact that some of it's methane, some of it's CO2, and in the flare there's also uncombusted methane that gets released as well. So all of that is worked out in the background into this donut. So that's just maybe one thing to start on. I think the other thing to note is that this, although we've pushed quite hard on the rotating story here, there's another story going on absolutely in the background around flaring and venting, and we recognise we have probably just as many commitments made both internally and externally around flaring and venting, and that also gets kind of fed into that dilemma of which of these all very important issues should we focus on first. Especially in the onshore space, where flaring is much more of a societal impact, visually and kind of noise. Maybe there's other reasons why you might focus on those ones in the onshore environment than in the offshore environment. Chris, maybe you want to talk a little bit on some of the opportunities being worked.
Yeah, so one of those that you showed in the list was the St. Fergus vent to flare. So I think there was, or I can't remember which plant it was, but there was an opportunity looking at for vented gas, whether that gas that was vented, are there opportunities on our platforms to move vented gas to flared gas, and for the compressors that we have on the platforms, we have from the compressor seals, there's gas that's vented that could otherwise be, well, I say it could be flared to begin with, but actually what we want to do is capture that and recompress it back into the process and not have to flare that gas at all. So there are opportunities looking at how do we reduce the overall flaring and venting impact, and one of those is trying to direct vent to flare, but there are also opportunities to actually recover otherwise flared gas, put it into the process. There's also nitrogen purging instead of fuel gas purging, which is another option that's being looked at. I think there has been mention before of how to, recover with, I think it's called vapor recovery units. That some assets have that already built in. So there's all sorts of these kinds of projects that are being considered at the moment. But similar to what we're doing here with the rotating equipment type opportunities, is see how do we best replicate these opportunities from asset to asset, how can we have a widespread impact on overall flaring and venting reduction in our portfolio. So yeah, there's probably we had one or two extra slides on here to talk about flaring and venting with rotating equipment, but yeah, we timed out a bit, so didn't manage to run through that today. But yeah, it's a whole topic in itself, to be honest, that we probably couldn't cover in this one today.
So you actually invited yourselves back for another one. We are actually out of time, but it does show that, and thank you for your insights today and sharing some of the work you've been doing. Yeah, and I think as Bob and Neil and that have said in the chat, these are very complex challenges that we are facing, and as a technical people and engineers, some of the people that are on the call, it's a great opportunity for people to start working on exciting new parts of projects to help decarbonise and as part of that energy transition. So for me personally, I'm quite looking forward to the future and supporting lots of companies, whether they're from the development community to the operating community, to help meet our targets and hopefully get the right investment behind us and show that the energy industry is part of the future of our energy transition mix. So thank you, Chris and Rob, for your time today, and for everybody else joining us. Hopefully the weather is kind to you all out there. Does seem to be slightly challenging at the moment. out in north of Welland. So thank you once again, and take care, everyone.
Thanks, Rebecca.
Thanks, Rebecca.
Thanks, everyone.